Hello, students. Welcome. This is Mr. Campbell here with our first lesson of the week, starting here on a Wednesday after I spent all day yesterday cleaning up my classroom. And unfortunately, I still didn't have enough time to clean all of it out. So I'll be switching rooms again next year. I think I'm going to be in E Hall next year for those of you guys wondering to know that. But yeah, so it takes me a little more time than others because I got to get everything out and move it to a whole into the classroom. So I will be doing more of that Thursday a little bit. But I will try to get as many of these lessons out this week as I can, at least 3 for sure, as we get to our next unit quiz. Speaking of which, what the updates, grades being updated, I'm going to grade vocabs, I think, right after this video lesson, the recent, or not vocab, the recent assignment, maybe it was vocab, the Unit 8 vocab that you guys turned in on Sunday, I'll grade those probably today, hopefully. And then we've got the Doppler worksheet, which I posted. That is due on Sunday. Again, it's just a series of multiple choice questions with a few writing questions. Using your notes and research will help you get all of those answers. Shouldn't take you too long. I believe that is 25 points, so turn that in as soon as you can. Do your best. It should help you boost your overall grade. And then lastly, we will have our notebook check, our next one, starting this Friday, and that will be due the following Wednesday, which will be, I think, maybe our last week of e-learning. So I'll give you updates on that as we go along. As for our Go Blue, we've got to know from our electromagnetic spectrum chart. It was what we left off on last time, right? We look up here. We got to know frequency versus wavelength. We got to know the colors, right? That's going to help key high energy, low energy. Those are going to be a lot. You're going to see a lot of this on the next quiz questions. You're going to see a lot of this in the future in notebook checks. So make sure you drew this chart out on page 13. Okay, make sure you drew that out, sketched it out. Doesn't need to be in color unless you'd like it to be in color. Roy G. Biv, know that, right? So let's get to those questions. What type of wave has the A, lowest frequency, and B, highest frequency? And 2, what type of wave has the A, longest wavelength, and B, shortest wavelength? Let's go ahead and check out. Take a moment to think about it, write your answers. Okay, looking here. So the highest frequency is going to be gamma rays, lowest frequency, radio waves, right? And then longest wavelength is radio waves. We see because, again, frequency, not as frequent, right? They're flowing at a much more spread out rate, which means their waves are longer, hence why they have the longest radio waves, right? And then the shortest wavelength, obviously because they're high energy, high paced, is going to be gamma rays again. So to keep it in short, number 1, A is radio waves, B is gamma rays, and 2, A is radio waves, B is gamma rays. Again, radio waves are the lowest frequency, gamma rays are the highest frequency, radio waves are the longest wavelength, gamma rays have the shortest wavelength. Here is our table of contents, guys. Go ahead and update pages 14 through 15. We're going to be star life cycle. Again, all we're going to do today is draw a chart and explain the star's life cycle, maybe go over 2 different categories. But the key thing to know is what is the lifespan of a star like? How are they first created? How are they created? How do they cease to exist? So we're going to go over the step-by-step lifelong process of a star here a little bit and go over more details with it tomorrow as well. Okay, which of the following colors has the highest frequency? And that should be a question mark. Let me go ahead. Oh, I don't want to give away the answer. Don't look at the answer, guys. It's kind of too late. I can't really help it. But try not to look at the bottom left of the screen here if you do want to test yourself. But which of the following colors has the highest frequency? So go back to your chart here. Look here. Again, highest frequency. I have low frequency, high frequency. Again, the higher energy, the higher the frequency. And it is going to be violet, guys. Okay, so again, Roy G. Biv, blue, indigo, violet. Those are going to be higher in frequency. So A, blue, B, red, C, green, or D, indigo. Oh, out of these 4, then, which are going to be the highest frequency? Which is the closest color to violet? It's going to be D, indigo, which is like a very strong blue color. Okay, so know that for the future. All right, go to page 13, guys. All I want you to do is just to label this wavelength. You guys probably remember this from physical science or chemistry before. Whoa, I'm getting ahead of myself. All right, and here we have a typical wavelength. We've got to know the different parts of it, right? So the crest is the highest point of a wave, okay? The trough is going to be the lowest point of the wave. The amplitude is, again, the height in which the distance in which it reaches from its moderate point to its highest point. And then the wavelength is the starting point, the length of a wave from the starting point to that same starting point, right? So again, crest is the top, trough the bottom, amplitude and the range and the wavelength is the length of it from start to finish, right? So let's go over those in more detail. Again, make sure to draw that on page 13, label it. Don't need to write these here on the right where my little camera screen is. All right, so what are some of the details we need to know about these waves? Take a moment. You need to pause this video. You need to write these out. Here we go. I've got it all spread out for you, okay? Crest is the top of the wave. Trop is the bottom of the wave. Visible light, waves that have a color spectrum of Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, okay? Infrared, what's special about those? They're off, and this was kind of one of our videos from last week that was mentioned. Infrared, used in heating lamps, right? Used to kind of look at the heating, the body temperature, right? If you're in a forest or you're in a snow-covered area to find somebody who's lost, right? Gamma rays, the strongest as we know. Waves that have the shortest wavelength and the highest frequency. X-rays, I know a lot of you guys have heard of X-rays before, used to commonly scan our skeleton to scan for injuries and such, right? So they go through solids in doctor's offices to go for broken bones. Frequency, the number of waves per unit of time. Microwaves, waves are leftover energy from the Big Bang. Ultraviolet, from the sun, causing a sunburn, right? Waves cause sunburns with prolonged exposure. Radio waves, again, used by bats to communicate, dolphins to locate food. We also know, super important here is the word sonar. We got to know sonar, okay? So radio waves used for communication. Wavelength, the distance between one point of a wave to the same point on the next wave. And lastly, amplitude, the maximum distance it reaches from its resting position. So make sure to copy these, write them down on page 13. Super, super important, guys. We need to know these. There will be several quiz questions on these coming up in the near future. All right. So with that, did I skip video questions? Let's see. No, I did not. Okay. So some things to think about here. What are some of the names of the different star types? And what factors do you think determine the life cycle of different stars? So maybe it's the composition of those stars. Maybe it's the size of the stars, right? So that's some thoughts. So questions include, what stage is our star in the sun right now, and what stage will it die as? And two, what stages do larger stars go through when they die? So maybe when our star isn't maybe a massive star, albeit it's massive in our solar system, right? But compared to other stars that we see in the sky, maybe not as large or large in size in comparison, right? So what stages maybe do larger stars go through? I'm going to go ahead and show you guys a little clip here from the video. The full-length video will be posted on Edsby for you to watch on your own. Okay. And let's go ahead and see just a little snippet of this here.
Stars initially form from clouds of dust and gas. The force of gravity makes the dust and gas spiral in together to form a protostar. As the gas and dust falls together, it gets hot. A star forms when it is hot enough to fuse hydrogen nuclei into helium.
Okay, so you guys will be on you to watch all of that on your own. But key things we saw here, some gas and space dust, were maybe the ingredients to first beginning our star, right? The first beginning our star. So let's walk through the first two stages here. Okay. I'm kind of playing catch up a little bit, guys, so be patient with me as I give you a lot here. So go to page 15, title this Star Life Cycle Notes, Star Life Cycle Notes. And what I want you to do first on the first top half of the page is to draw this image here. Okay, oh, got way ahead. I've got two vocabs and then one image to draw. Oh man, Mr. Campbell. All right, so go ahead and draw this image on your, with all labels in class. I would have given you this, but it would have had blanks, right? And we would have gone through it together. But since we're not in class, we can't see each other in person, you guys will just draw this from scratch and label it as well. So that early star that we saw in that video, again, star formation, right? Okay, which includes the stellar nebula and protostar. So think of a protostar as like a baby star, it's the beginning stage of a star. Again, guys, make sure to pause and get this before we go over our discussion. All right. Then as the star continues and grows, if it's a low mass, less massive, or massive, it will all get into what we call the main sequence. So label this area the main sequence. Okay. Okay, don't be surprised. It's an important drawing. Maybe I might ask it on a notebook check. So our sun, as we know it, as labeled here, is a less massive main sequence star. So pretty medium in size and compared to most stars in the universe. Okay. Now, what's going to happen to our star over time. Our star, scientists have estimated that our star is halfway through its lifespan, a couple billion years old. As it begins to run out of those essential gases, the helium maybe, it's going to start producing iron, which is going to lead it to its death. But before it does that, it's going to actually get larger in size. It is going to become a giant. It's going to cool down and turn red. Again, supergiant or giant. If it's low massive, it just becomes a red dwarf, right? Now, the sun, again, less massive. It's going to begin to die as a planetary nebula caused by potentially a it may kind of just fizzle out, maybe a supernova, but not as large as a massive star. The bigger the star, the more likely it's going to have a supernova, okay? Key thing there, okay? When it's a supernova, if it's the highest mass it can be, you could get a black hole, okay? That's going to eliminate and drain everything around it. It's going to take in all matter, light included, all around it. Scary situation to be in. Regardless, all the planets are gone anyway. They're all disintegrated by the explosion of a supernova. Okay, high mass, then it might if it's not as massive, but it's still high, it can become what we call a neutron star, neutralized, not a black hole. We'll talk about that in the future, probably tomorrow. Lastly, what will happen to our star? It's probably going to fizzle out into a planetary nebula. That means what's going to happen is it's going to get larger, and then the outer layers are going to just kind of disperse into that nebula. And all that will remain is the white core of our planet. We call that a white dwarf. And kind of like a battery, it'll just fizzle out, and then our solar system will cease to exist. Okay, so let's go over vocab for two things we mentioned there. Write this on page 15, guys. A protostar, what is a protostar? It's a contracting mass of gas that represents an early stage in the formation of a star. Think of it as the baby star. It's the star at its earliest stage. It's fusing, it's spinning, it's being created. And then lastly, guys, stellar nebula, which is included around that first protostar, right? It's a cloud of superheated gases and other elements formed by the explosive depth of a massive star. So where one star dies, it leaves in that nebula a bunch of gases and a bunch of elements. Many, many years down the road, that could create a new star. So we have birth and rebirth of stars happening all the time. It's just a matter of those gases and those particles and those elements fusing together, nuclear fusion, right, to ignite that star like a firework and create it into a protostar, right? So our last activity of the day, guys, which of these star types marks the beginning of life for most massive stars? What is the baby star? Should be a piece of cake, should be pretty easy, you guys just heard about it. Is it A, a white dwarf, B, a protostar, C, a neutron star, or D, a main sequence star? Think about it. Correct answer is going to be B, protostar. That concludes our lesson for today, guys. Check out that video. Again, get this stuff done. I know it was a lot on page 15, and just be patient with the drawings and things like that. Those are really important. I'm going to grade for those likely. Again, there's no way I could give you the sheet that had the drawings already. So be sure to just draw that on your own and label it. It'll help you a lot for some future questions. Again, don't forget, Sunday, we've got the Doppler worksheet due. We've also got the notebook check coming up. And if you are a senior, I forgot to mention, seniors, you guys are all done. Everything we got this week, you don't need to participate in it. It does not impact your grade, okay? So if you have questions, send me a message about any of your assignments or classwork. Again, I'm being a little open with grading and flexible with some grades, so anything that's late, turn it in. You'll get some points for it. It'll increase. It'll definitely boost your grade. So take advantage of that. All quizzes are still open. Mr. Campbell, signing out.